All right, everybody, what's up? Pre-calculus. Mr. Smith coming to you on a Saturday afternoon. And this point of this video is to learn our very last identities. Now, for those of you who are in my class, I'm going to sneak a random trivia question about myself somewhere in this video. And then when you come to class on Tuesday, I'm going to ask you the question. See if you watched the video or not. Granted, I know that someone could just watch it and tell you the answer, but then I'll find out that you didn't watch it when you fail the test. So it's your call. No, I'm just messing, but I am serious. But these are our last set of new identities, and so I'm going to explain them in the notes. And there's really three parts. There's these types of questions, which are the only proofs that actually have angle measurements in them. It's not even really a proof. It's just a way to practice these identities, really. So these are the identities. We'll fill those out. Here's a couple problems we'll try together, and then here are the proofs. They look kind of like this. These are medium levels, and these are hard levels, and we'll do both. So let me dive in without further ado. These are called the sum and difference identities. All right. Why are they called that? Well, think about this. I hope you see the pattern. Sine of 2x is called the double angle because the angle is times by 2. We learned the other day sine of x divided by 2 is called the half angle. Well, it's being cut in half. So why are these called sum and difference? Well, notice you're adding two things together or you're subtracting two things. Okay, so these are the sum and difference identities. And I'm just going to put them out here. You're going to notice a pattern. You can even go to a YouTube video if you want. Right here, there's plenty of them. Derivation of the identities to see where this comes from. But I think at our level, I just say you trust me and Mr. O that these are true. Okay? If you see sine of something plus something. Okay, this says a plus b, but remember, this is a formula. It could be like sine of 2x plus x. But just remember, a and b are like placeholders, okay? So here are the identities. Sine of a plus b equals sine of whatever a is times cosine of whatever b is plus cosine of whatever a is sine of whatever b is. Okay, that's the first one. What about the subtraction version, though? That's the exact same, actually, but with a minus. Okay, so it's still sine of a cosine of b minus cosine of a sine of b. So those are when it is a sine sum and difference identity. That's the pattern. What about when it's cosine? What about when it's cosine? Well, that's slightly different. Cosine of a plus b is actually cosine a cosine b. So both of them are together. And then it's actually an opposite symbol. So when there's a plus on the inside, there's a minus in here. Okay, so little tricks that you can see to recognize the pattern. I recommend, sorry, I forgot that equal sign. I recommend that you practice these for sure. On the actual proofs portion of the test, right? You'll have these written down. So you don't really have to know these, like memorized. But I could see them on the identities, there maybe being like a matching or a true false, where you'd want to know kind of the flow of those. So I'd honestly pause this video right here and just look for as many patterns as you can. And that's probably the best way to memorize these, because once you've looked at the patterns, you'll feel a lot better. All right, so these are called the sum and difference identities. We will use these for the rest of the way through. So it says, look at number 1. Use the sum and difference identities to evaluate the following. Sine of 15 degrees. Well, darn. We've learned so far that sine of 30 degrees is 1/2. We know that sine of 45 degrees is square root of 2 over 2. We know that sine of 60 degrees is square root of 3 over 2. I could keep going. We've learned a bunch of different values on the unit circle, but 15 degrees was never one of them, right? So what we're going to do is use a sum and difference identity, and we're going to break this into, instead of sine of 15, we're going to rewrite this as sine of 45 minus 30, which I'm sure you know is 15, so that's why we're allowed to do this. And then we can expand it using one of these 4 identities. We're going to actually use this one, because this is the one where it's sine of something subtracted by something. And what we created was the sine of something subtracted by something. So let's just look up and use the identity. Sine of A, cosine of B. Well, in this case, A is 45 and B is 30. So sine of 45 cosine of 30 minus cosine of 45 sine of 30. If you've forgotten all of your unit circle, that's why I put this chart over here. Okay, just remember, we need to memorize this. Okay, remember 0 degrees, anything over 6, anything over 4, anything over 3, anything over 2. But we need to remember sine of 30 is 1/2, sine of 45 is root 2 over 2. We need to memorize this quadrant 1. So sine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2 minus cosine of 45 is square root of 2 over 2. And sine of 30 is 1/2. Square root of 2 over 2 times square root of 3 over 2 will be square root of 6 over 4, because you just multiply straight across with fraction, minus square root of 2 over 4. And the square root of 6 over 4 minus the square root of 2 over 4 equals the square root of 6 minus the square root of 2 over 4. We cannot subtract those square roots because they have different bases, but that is our solution. Okay? So I'm close to the halfway point in this video. What I would recommend that you do is that you try any of these, number 2, number 3, number 4, and all you really change, you use these to guide you, but all that you really change is like, how can I get 75 using unit circle values, either 30, 45, or 60, or 90 even. It's like, how could I get 45, 75? Oh, what if I did cosine of 30 plus 45? Yep, that would work. This one down here, 105, that's going to be another addition problem. I'll let you figure it out. 15 is going to be subtraction. So pick one of these, 2, 3, or 4. Set up your problem, and then look up here and use your identities to expand it. And then to get the actual numbers, like the square root of 2, square root of 3, you just use unit circle. So I would challenge you to try one of those. Pause, rewatch me do mine if you need some help. But we got to move on. Okay, so down here, let's do, I'll do one medium and one hard, and then we'll pick up where we left off tomorrow. I'm going to do number 11 just to show you how it looks complicated, but it is super easy. Okay, the reason it's easy is because if you see a proof that has a cosine or a sine and then like something minus something or something plus something, like we know that we are going to use the cosine of A minus B. We're going to use that identity that's up at the top of our sheet. Okay? So I know that the cosine of A minus B expands out to be cosine A. Remember, this is A and this is B. Cosine A cosine B plus sine A sine B. Excuse me. And we're trying to get it to equal negative cosine. It's like, Smith, that is really not even close to negative cosine. It actually is. Check this out. I love it when a plan comes together. What is cosine of pi? That's cosine of 180 degrees. Told you the unit circle was coming back. The cosine of 180 degrees is negative 1. And there's your negative cosine. But what about this? Okay, what about it? What's the sine of 180 degrees? What's the sine of pi? I challenge you to pause it right now and think unit circle. What's sine of 180? What's the reference angle? What's the quadrant, etc.? Sine of 180. The reference angle is 0, and the sine of 0 is 0. So wait a minute. What's the sine of x times 0? That's just 0, so that cancels. Wait, you're saying that I'm done? That's what I'm saying, boss. So we're about to do a hard problem. That's going to take our last 5 minutes. But on these mediums, if you see something like this, like, oh, that looks scary, Smith. No, it doesn't. Expand this out. This is the sine of A plus B. Use your identities. This is the sine of A minus B. Use your identities, expand it, and good things will happen. Okay, so those are the medium levels. Same thing with there. This is the sine of a plus b. You can expand it out. Okay, but let's do a hard level. Let's do 14. Wait, look, how many 13s do I have? 13, 13, 13. Yikes, that's confusing. Let's do this 13. Okay, sine of 4x. Alright, I'm going to put the trivia question right here in the video because this is the most important part of the video. So after this trivia question, don't go anywhere. But my two favorite cities that I've ever been to, my favorite city in the U.S. is New Orleans, and my favorite city outside the U.S. that I've ever visited is Istanbul, Turkey. It's magical. So if you ever want to ask me about New Orleans or Istanbul, let me know. I got stories for both. Alright, here's the most important. This is going to go counter to everything that I've taught you so far. But when we see a 4 next to the angle, or if we ever see a 3 next to the angle, believe it or not, that's actually the side of the proof that we start on. I know that looks more complicated, but we actually, when we see a 3 or a 4, we're going to start on this side and make it equal that. Okay, let me show you. First thing I do, sine of 4x is actually a sine of 2x plus 2x. Remember, every problem I do today on this assignment, I'm using the sum and difference identities. That expands to sine of a cosine of a. Does it match when sine is plus? It matches, yeah. So plus cosine of a sine of b. Whoa, okay. So here is our next level. And now, I know you're not used to these yet, but we did just do a lot of them today in class. These are now double angle identities. This changes to something, this changes to something, this changes to something, this changes to something, right? Identities number 9 and 10, right? The double angle identities. So we got sine of 2x, which turns into 2 sine cosine. We've got cosine of 2x, which can turn into 3 different things. That's going to be tricky, so we'll pause that for a second. This cosine of 2x can turn into 3 different things, so we'll pause that for a second. And this sine of 2x turns into 2 sine cosine. So I like sine of 2x because that only has one choice. But look up here. We've got to decide what do we want to turn this one into. And when I look at the right, I see cosine cubed here. I see sine cubed here. So the fact that one of them has a cosine cubed and the other one has a sine cubed, I'm thinking that I'm going to use the 2 variations. Remember, we've got these 2 variations. I'll show them to you. The 1 minus 2 sine squared and the 2 cosine squared minus 1. I think I'm going to use each of those. So I think one of mine will be a 1 minus 2 sine squared. And I think this one will be a 2 cosine squared minus 1. Now I'm going to go really fast during this last minute. I want you to pause and go watch it again. But here's what we're going to do. We are going to take this term, which is just one term. I'm going to multiply it by that and that. We're going to take this, which is just one term, multiply it by that and that. Okay, so what I get is, when I expand it, 2 sine cosine minus 4 sine cubed cosine. That's what I get from that distributive property, plus, and then over here I get 4 cosine cubed sine minus 2 sine cosine. At this point, I only have one step left, and it is to combine like terms. And I actually think I'm done, because check this out. This 2 sine cosine right here cancels out with this negative 2 sine cosine right here. And I think my final answer is this. I'm going to run out of time, but you get the idea. That's my final answer. let's get after it tomorrow in class, and we will do our thing.